In this video, I'm going to show you how we turn the xiao module into a scope. So far, we've been taking data at some averaging time and then pushing it to the serial link, which we can display on the monitor or the plotter. But if we take data, as we saw, with an averaging time that's like 4 milliseconds, so that's 2 seconds full scale on the serial plotter, it's going by a little too fast. Can't see it. And so what we'd like to do is emulate what a scope does. We're going to take data as fast as we can. Instead of wasting time in that loop where we're taking data to print it to the serial plotter, which we can't even see it go by anyway, we're going to push it into an array. We have 500 data points across the serial plotter. And so we're going to collect 500 data points as quickly as we can, put it into an array, and then print that array to the screen, wait a leisurely amount of time to look at it, and then do it over again. And that's basically what a scope is going to do. And so we're going to create a couple of new variables. These are going to be arrays. And we want to do it as absolutely fast as we can. And so we're going to create a few arrays first for the raw data, so that we can collect the raw data initially, and then we're going to convert it after we've taken the data. We're going to convert it into the appropriate units, and likewise we're going to generate the time interval per point as well. We're going to assume that once we get our for loop going, it's going to take the same amount of time to take each data point. So let's start out initializing some variables. And so I pulled out the counter variable as well, and I made that a long so that it's in the main code. So it becomes a global variable. We're keeping the averaging time here that we had before. I'm going to move that back to 4 milliseconds, although we're not going to use that in this scope because we can't afford to take the time to do the averaging based on time with while loops. We have to use for loops that are much faster. And so we're going to assume that, okay, when we take the data, we're going to push it into some arrays. Now, the first array is going to be the array of the raw values from the ADC in units of ADUs. And so this is going to be a long array. And again, I like using variable names that are self-documenting. And just to remind myself, oh yeah, this variable is an array, I'm going to use the letters AR ahead of it, and this is going to be the voltage from the ADC channel 1 in ADUs. And the dimensions of this, I want 500 points, but I really like starting with an index value of 1. It makes a lot more sense. I don't have to keep track of subtracting off the index to get the first point. And that means I start with 1, and the last one is 500, because the index of an array starts at 0. I'm throwing that point away. I'm not using it, but I still have 501 points in my array. So there's the size of my array. One of the nice things about the xiao module is it has a lot more memory. This is using the SAMD21 microcontroller, a lot more memory than the Atmel 328 microcontroller that's used on the Arduino Uno, and it's got very limited memory. And so I can use arrays as large as 7,000 elements, even floating point, for the xiao module with no problem. So this is going to be the first array. I'm going to push the data as fast as I can into this array, and then the next one is I want to process it and turn it into a voltage, and I also want to display time as well. But these are going to be floats, so I'm going to have an array for the voltage from ADC channel 1, but in units of volts, also 501 points. And later, if I want to create a lot, take data quickly and put it into a file, for example, then I'll do the same thing. Push it into the array as quickly as I can, and then after I've gotten all the data, then I'll print that to the serial monitor or print it to a file and have that as a comma-separated variable file that will have time, comma, a voltage. And I can use that in either Excel or even read it into ADS or some other tool if I want. And so I can have an array size as large as I want, up to about 7,000 points, no problem. And so the last one is an array about time. And this is going to be an array. This is going to be time. The units for this are going to be in seconds. and this is going to be also 501 for now. Later, I can make it a large array if I choose to, but if this is going to the serial plotter, I can only plot 500 points at a time. Okay, so I've got these new arrays, and now we're going to create a new function, which is the scope. I'm going to put a new tab up here, so I'm going to come over here, create a new tab. I'm going to call this my new function, and this is going to be called scope. And I'm going to make life easy for myself, so this is going to be, the first line I like to use is just what it is. This is going to emulate a scope, take data as fast as we can. Okay, and now of course I need to start it, so it's void, because I'm not going to use passing data to this function in the function call. I'm going to use global variables to pass data back and forth between the main code and the function call. And so this is going to be a function. This is the name I've created, and I'm going to call this scope. And we are ready to go. And here's where we're going to put all of that code for this scope function. And so we're going to just start it out. And remember, we're going to use a for loop to take the data and push it into the array. So it's going to be a for. This is going to be I equals, I'm going to create that inside here, integer I. So it's local. I is local to this for loop. It's going to start at 1. I'm going to keep doing it as long as we are less than or equal to 500. Less than or equal to 500. And then I'm going to increment it each step. And there we go. And now this is going to be where I want to do things really fast. I just want to take the data and push it into the array. So this is going to be the array of the voltage from ADC channel 1 in ADUs. And this is going to be for each index value is going to be reading it. So this is going to be analog read from channel 1. And that's it. And so I'm going to take that data and shove it into that array, and we're done. Now, I'd like to know how long it takes to execute this, and then I'm going to divide by 500, and that's going to be the time per point. And so I'm going to start up here with a timer. Now, if we go back to the main code, we don't have any timers initialized as variables here. So we're going to create that in this loop, in this function, and it's going to be local to this function. So I'm going to create a timer. So it's I timer 0, and this is going to be I'm going to initialize it as the current time. We start the timer, we take all the data, and this is going to be the total execution time. So again, I'm going to initialize it here in this loop. This is going to be and I'm going to turn it into time in seconds. So this is going to be a float, and I'm going to call this total time, float of total time in, call this in microseconds, and this is going to be equal to the time right now minus that start time. And it's case sensitive. And I just want to make sure that I'm consistent, and I add units to any of my variables that are appropriate. So we start the timer, and then over here we measure the total time. And that means the time per point is going to be this amount of time divided by 500. So now we're ready to do the processing. So I'm going to use another loop, and we're going to push this into a calibrated the voltage array and time array. So this is going to be, again, same loop for, and now it's a different, a for loop is a function. And so this variable I was local to this function, and so I'm going to create another variable I local to this function, this for loop. It's for I less than or equal to 500 as well, and we're going to increment I and then we're going to create another for loop. And in this loop, we're going to take these values, and now we're going to do our calibration. So we've pushed that data as absolutely fast as we can. And while we're here, let's create another variable. This is going to be float. And in fact, just to save variables, let's do here time per point, and it's going to be this much total time. And so we're kind of writing this code as we go, because we have an idea of what the algorithm is. We're just going to optimize it a little bit and divide it by 500, and because this is a float, I'm going to make it 500.0. So this is the time per point. This is the total time divided by the number of points. Let's see, and so we're going to go, here's the array. In this array, or in this for loop, I want to take the voltage on ADC channel 1 in volts is going to be this guy. Oh, and this is the array, so remember that's why I like having the RR in front. Array of the ith point, and it's going to be this value here. And now I have to normalize it. So this is 0 to 4095, so I'm going to divide this by 4095.0, and then I need to scale it by the total voltage. And remember, this is why we self-documenting labels. So this is a voltage, this is on the DAC, this is the reference, and this is in volts. So don't even have to look it up because I remember the format for it. And so I've just taken the integer, the analog to digital unit value, I've scaled it by how many data points in the 0 to full scale, and then that's the fraction of full scale, and here's the value full scale. This is now the voltage for that data point. I'm going to do the same for time. I'm going to create an array for time in seconds, and this is, each one of these is going to be the initial value I times the time per point, which we created up there. It's time per point in microseconds. So that whole thing now is in microseconds, and I need to multiply that by 1e to the minus 6, and I'm going to call it 1.0 just so that we make sure we have it in floating point. And so this is in microseconds, and now we multiply by 1e to the minus 6, and that's going to be in units of seconds. And so here are my two arrays, and we're done. So at this point, we can decide what we want to do. We can print them to the serial monitor. We can plot them on the serial plotter, just plotting the voltage there. But at this point here, we've got our arrays populated, and we've got the data as quickly as we can. So we can add some of those print statements. Now I'm going to steal them from, we already have those print statements in the taking data function, and so I'm going to just steal those values here, and we'll paste them here. Now I could save a little time, and hey, I'm already going through and building this array, and so while I'm building the array, I can print it as well. I don't have to have another separate array. So let's do that while we're doing this calculation. I've got the limits over here, the high and the low value. Not sure what they're going to be here, but this is a good starting place. Let's see, and so this is going to be the array that I'm going to plot, ARR of, and this is going to be the ith point, and I'm scaling it here. This is in volts. I'm scaling it here in millivolts. Now, initially, it'd be nice to see, hey, what is the time per point? Because I know that when I'm taking data as fast as I can, I'm going to get a value like around 14 microseconds, the acquisition time per point. It'd be nice to see how close to that am I getting. And so we can display that right here after we finished with it over here. I'm going to put a serial print statement. So we're just going to do this to the monitor so we can get an idea of what that time is. So we'll do a serial dot print, do a line feed, and I want to print out the time per point in microseconds. And then, for now, I'm going to comment the rest of this out. We'll come back to it later because I just want to see what's that time per point. I'm going to clean everybody up, and let's take a look and see what this is going to do. So we're initializing a counter. We're taking data as fast as we can, and we're pushing it into that array. And then we're done over here, and we're going to calculate the time per point, and we're just going to print it out, and that's it. We're going to be doing that 500 times, and we have already divided by the 500, and so let's see how many microseconds that is, and we'll see how large it is compared to if we just took data and put it into a regular variable. So we're going to run this scope function. Let's see, and so now, again, we saw before, what we really want to do is have code structured so that in the main loop, basically all we're doing is running functions. And so this is going to be the function. We called it scope. And then just so I have time to see that result, and now we're ready to run. And we'll just run this repeatedly, and we'll see on the serial monitor what the time is to take those each point when we're pushing it into an array. So let's run the code. First, let's check and see, hey, do we get any syntax errors? Is everything looking okay? So we're compiling, and see if so I typed it in wrong somewhere. Of course, here's the time per point, not timer per point. And let's do a check. Compiling. What else did I do? Let's see. I have too many of these. Let's see, and let's do a... Okay, so here's that void. I got that for loop. Oh, because I had the for loop over here, and I forgot to take out the little end here. So let's do that, and we'll have this, just so we're consistent when we go to unformat everything, to comment everything. So let's try it again. Do we get everything? Compiling. Cool, no more errors. Now let's push it over. Okay, now let's look at the serial monitor and we'll see how long it takes to push it in. Wow, look at that. It's also 14 microseconds. And so pushing it into the array is not taking any extra time. So we're really going to do this as absolutely quickly as we can. So that's really good information here. I'm going to leave this in here for future use. And now we're ready to, got all the data, it's in an array, and now we can process it. So I'm going to uncomment all of this stuff out. And now we're going to take that data, we're going to scale it, and in this case we're also going to print it out. And we're going to just print this right now. We know the time per point. We're just going to print the voltage values out, not the time values. Let's just clean this up just a little bit. Here we go. And now that's good because I saw, oh, I missed a semicolon there. And now it's nice and neat, looks great. And so we're going to print this as serial monitor first, just make sure we get the data coming out, and then we'll go to the serial plotter. Now, keep in mind, this is going to take data really fast, and it's going to send it to the, do the calculation, and then print out this really fast. And so, in order to look at the data, especially when it's on the plotter, each time we take it, I want to add a delay in here. So this delay is going to be, let's call it 5 seconds. That should be plenty of time to look at the result. So now let's run it and see what we get. Okay, and we got it going. We're ready. Let's take a look at it. So serial monitor first, and here are the upper lower limits. Here's that data coming out from the array. Okay, very good. Looks great. I think it's ready to plot, and we're within those limits. So let's go and clean up our scope function, and everything looks good. We get the high and the low, and I think we're ready to plot it. So while it's coming out, let's go to the serial plotter. Oh, I have to close the serial monitor. We go to the serial plotter, and there's our data, and it's scaled. This is like taking data from a scope, and we're doing every 5 seconds. So here's the data. It's as absolutely fast as we can, and we can see there's a lot of noise on it. And so at this point we can decide, do we want to do any averaging? And we could average for a certain number of points. That would clean it up a little bit. And so we can come over here, and now we can modify this. So maybe we should add a variable here that when we're taking data in the scope function, we can have number of points to average. And so this would be an integer. We'll call this number of points to average. And let's say, let's take 5 points. So the way we're going to use this is we're going to come over here to our scope, and now here's where we're taking the data and doing it really fast. And so we come over here and we're going to add another for loop, and this is going to be for, and this is going to be averages. So I'm going to use a new variable j, which is going to be the number of averages, and this is going to equal the first average to j less than or equal to number of points to average. And that is a global variable which will come over, and then I'm going to increment j. I'm going to create that for loop, and now this stuff here I'm going to put into that for loop. And instead of just taking the data, I want to add to the previous values. And so I'm going to add to the previous value in this loop. This is going to be our running sum, but in order to do that, I've got to, before I start that process, I have to initialize it, and so I need to set this equal to 0. So we're using this array, that index value, as our running sum, where initialize is 0. We're going to take data and keep adding it up for the number of averages we need. We're done over here, and we've got the running sum in that array. Let's clean this up so we can see everybody nice and neat. There it is. We got the running sum. We're done with the number of averages, and the same way here. This is when it starts. This is how long it takes to do all those averages. This is still the time per point, because ultimately we end up with 500 points. It's going to take longer because we have more averages. And you know what? Let's just check and see. We'll print that out. But now when we do this normalizing here, we need to add the divide by the number of points that we're averaging. So it's the number of points to average. That's an integer times 1.0, and then we normalize to the total number of points that we have in the full array. So this is the running average. This is now divide by the number of points. So this is the ADU value average per point. This now scales it to full scale in ADU, and then this scales it to the voltage. Okay, now we're ready to go. Now, with the averages added, we want to just see, well, how long does it take? Because if I set the average for 1, I hope it comes pretty darn close to that value of 14 microseconds. So let's, again, comment out all of this stuff here so that we can just display on the screen what the number of the time per point given all this averaging that's going to go on. So again, let's check everything, make sure I didn't type something in wrong. Okay, let's see. Okay, so I need to initialize all of these guys to 0 so that when we start out, we're going to add to the previous value. I want the previous value to be 0. So before I enter this loop, I need to make each of the i's 0. And so I need to add a loop here, which is going to be 4, and I'm going to use the same value of index, because each loop is independent. They're separate functions. I'm going to keep this local. I want to have I less than or equal to 500. Should be I less than or equal to 500. And then I'm going to increment I. Okay, so let's see. So I'm going to do these averages. Now, because I'm starting out, I don't need to put this in the loop that is doing all the averaging. That will take up more time. So let's take this loop here and let's put this at the very beginning. So now, because everything is about speed, for now, I'm going to start out, I'm going to initialize all of those index values in the array. I'm going to set them all to 0. Then I'm going to start the timer. This is going to be for the number of averages that I want. I'm starting out with the initial value of 0, and I'm just going to add them all up in here, and then we're going to continue. So now I think that's going to do it. No errors. Great. Okay, I think this is going to do it. So I'm going to use an initial value, number of averages. Let's use 1, because I'd like to see if I use 1, then am I going to add any additional time, execution time, to this array? Because j is going to be 1 here, and as long as this is true, I'm going to execute this once, and then the number of averages is 1, and I ought to get the number of points to be just slightly more than 14 microseconds. So let's run it and see. And now I've commented everything out. So when we look in the serial monitor, we ought to see the time per point being this time. And because I was running stuff on the serial monitor, I had to shut it off, and now we can upload the code. And let's look on the serial monitor, and we'll see the time per point. Wow, look at that. If I use averaging of 1, the execution time is virtually the same. And so it's taking me the same amount of time whether I use average of 1 or 2. Now, let's try average of 2 and see. It ought to be about 29 microseconds per point. So let's try that. So averaging of 2, and I'm hoping to see 29 microseconds per point. Okay, and let's take a look. There it is, 29 microseconds per point. So I think we've got it. Now we are getting the data. It's going into the array, and I think we're ready to plot it on the serial plotter. So I'm going to set the average back, keep it at 2. We're going to go into the scope function here. I don't need to print this line out anymore, and we're going to uncomment the stuff over here so that we can now print it to the serial monitor. So we're going to take it into an array, we're going to do the scaling over here, and we're going to look at those measurements coming out in millivolts. So let's upload the code. Now when I'm printing to the serial link slowly, I can probably upload without having a problem, because it's not always sending data on the serial link, and I'm just grabbing it when it's not sending data, and I can upload then. It's when I'm streaming really fast stuff to the serial monitor that it gets hung up a little bit. So let's take a look at our serial plotter. Oh, I have to turn off the serial monitor. Well, here's the serial monitor, the limits, and here's the voltage that we're getting. That's a good sign. And now let's turn on the serial plotter. And there we go. And we're taking data with an average of 2 points. And so that means that it's about 29 microseconds per point. And there it is. And now if I were to go to, maybe we're on a roll here. Let's do 5 points. So let's see. Oh, I could do 10. 10 points. Let's think about that. 10 points at 14 microseconds a point. 14 and a half, so this is about 150 microseconds per point. So let's run it, and let's take a look at it. So this is averaging with a time interval of 150 microseconds per averaged point. And you can see the noise level has reduced, which is exactly what we would expect to see. And so we have, in this video, we have developed a scope application, and we've modified it to not just take data as quickly as we can, but now provide a little bit of averaging per point and plot those 500 points on the serial plotter frame by frame. Okay, and now we've got a tool we can use to look at data as it's coming in as quickly as we can.